these are notes for Thursday, May 3rd for pre-calculus. This is 10.4, and we are finishing the notes on hyperbolas today. And so we're just going to do this last example, example 3, and it says to sketch the hyperbola and find the equations of its asymptotes and find the foci. Oh, okay. So this is the recording for the rest of 10.4. And so here's our equation. I'm just going to write it again here. 4x squared minus 3y squared plus 8x plus 16 equals 0. So our first thing we have to do is get that in standard form. So we're going to have to complete the square and everything. So we'll go 4x squared plus 8x plus blank minus 3y squared and equals negative 16 plus blank. Now, that 3y squared, since there's no y term, that's just going to have a 0 for its center value, and so we can just kind of leave that as is. But then on this first part, we're going to distribute out of 4, so that's going to be 4 times parentheses x squared plus 2x plus blank. Close the parentheses, and we'll just leave that minus 3y squared equals negative 16 plus blank. And again, we said this the other day, but since we're putting those on opposite sides of the equal sign, we just add on both sides. So if we complete the square, and I'll just do that, but then I'll erase it. So we take the x term, 2 divided by 2, and square that. So that's 1 squared, which is 1. So we put a 1 there, but then what we're truly doing is we have this 4 times that 1. So over here, when we add, we're going to add 4 times 1 for that part as well. So just kind of some reminders of completing the square as we look at that. So then we can write this in factored form, and we'll figure out what that right-hand side is. So this is 4, and then x squared plus 2x plus 1 is parentheses x plus 1 in parentheses squared. And we'll just leave that minus 3y squared again. And then negative 16 plus 4 is negative 12. Now, we want that to be positive 1, and oh, look, isn't it awesomely amazing that 4, 3, and 12 are all divisible by 12? So we get the luxury of dividing everything by 12, and everything will kind of fall into place. However, it is negative 12, so we have to divide all the terms by negative 12 to make that right-hand side equal to positive 1. So divide by negative 12, divide by negative 12, divide by negative 12. And so then on the left-hand side, we get our x plus 1 in parentheses squared. And then 4 divided by negative 12, that's over negative 3 now. And then plus, this will be y squared over 4. So notice that became positive. So we're going to have to rearrange things in a minute here. Equals 1. And then really, since our y squared term is positive, we're going to move that all the way to the left and just rearrange. And so we're going to say y squared over 4 minus x plus 1 in parentheses squared over 3 is equal to 1. And so now this is in that general form, and I'll write the general form, y minus k in parentheses squared over a squared minus x minus h in parentheses squared over b squared equals 1. And so then what that tells us in this problem is that we can now figure out some things that are happening here. So in this case, our a and oh, I better write it one more time. So that's y squared over 2 squared minus x plus 1 in parentheses squared over, and this is 3, so it's like the square root of 3 squared equals 1. And then that gives me that a is equal to 2, and that's going to go up and down because the y is first. And then b equals the square root of 3, and that's going to go kind of to the left or right. And so this one, because y comes first, is going to have a vertical transverse axis. And so I'm going to write that down. It's going to have a vertical transverse axis. And so let's see what we know here. Well, our center, which is HK, has H this time, which comes off of still the X term. So I'll just kind of underline those in purple a minute. So H is -1, and K, which since there's nothing subtracted here, could be thought of as y minus 0 squared, then K is 0. So let me get rid of some of that stuff I just wrote on there. And so then that means the center is going to be -1, 0. The next thing I'm going to find is the vertices for this one. And so my vertices are going to be h comma k plus a. I'm going to just write that a little better. H comma k plus a in parentheses, and h comma k minus a. And just a reminder, I can't see it right now, but a was equal to 2. And so then our vertices will be at -1 comma 0 plus 2. So at -1, 2. And also at -1, 0 minus 2. And so -1, -2. So I've got those vertices. And then the next thing that I want to figure out is, let me kind of slide up a ways so I have some good room. The next thing I want to figure out is the endpoints of my conjugate axis. So the endpoints of my conjugate axis. And so for that, b is equal to the square root of 3. And so those are h plus b comma k and h minus b comma k. And so that'll be h, which is -1, plus the square root of 3 comma 0. And -1 minus the square root of 3 comma 0. And then -1 plus the square root of 3 on a calculator might be approximately 0.73 comma 0, so we can plot that point. And then -1 minus the square root of 3 comma 0 would be at about -2.73 comma 0. And so then the next thing I'm going to do is I'm going to use those things, and I'm going to draw my rectangle. Draw my rectangle. And then my asymptotes. And then I can sketch the hyperbola. And at the end, I'll get the equations of the asymptotes so that if I have to do that, I'm kind of ready to do that as I go. So I can't see everything, but I'm sure you have that in front of you. So our center is at, oops, sorry, I accidentally made that go down. Our center is at -1, 0. So we'll put that right there at -1, 0. And we have vertices at -1, 2, -1, 2, and we have one at -1, -2. So we've got those two vertices. We've got our endpoints of our conjugate axis, and those are at about 0.73 comma 0. So I'm going to just kind of put that right there, a little hard for me to just quite write. And then negative 2.73 comma 0 is going to be that other one. And then I will sketch in the box that I need. And a little bit of a challenge for me, but I am up to the challenge, I think. And I'll just make my box in this black color. So, and I'll just draw these as best I can, and then I'll kind of clean them up after I draw them. And so I'm gonna, oh, that one is way off. So I'm gonna move them and have that kind of, and I'm sure you're doing an awesome job on your paper for that. I'm not, of course. Maybe I will. I'll I'll do that from the actual computer. So let me. There we go. I'll make my box a little bit better. Oops. And oh, I guess I don't have that at quite the right place. So that's at about 0.7. And well, that's gonna almost be good enough because I can feel that I'm not getting great results there. There we go. And so then I have my box drawn, and now I'll draw in my asymptotes. And so my asymptotes just go through those corners of the box, so that's pretty straightforward to draw that. And then I can just extend those out so they're easier to see. And then I can sketch in. And so this is going to be looking kind of vertically up and down is where my hyperbola is going to turn out to be. So up there. And, oh, just a sec. And there's my hyperbola. Two more things we have to do is find the foci and also the equations for the asymptotes. And I think I'm going to just go to another slide and do the equations for the asymptotes. A was negative, or excuse me, positive 2. A is 2. B is the square root of 3. And so the equations of the asymptotes are going to be y equals k plus or minus a over b times x minus h. And so I'm just going to write it as plus or minus, then I'll break it apart. So y equals k, which was 0, plus or minus a, which is 2, over b, the square root of 3. So I feel like I'm going to have to get that in simple radical form eventually. Parentheses x, h is negative 1, so it'll be plus 1. And so then the next thing I'm going to do is, I think all at the same time, I'm going to rationalize that and just write my two equations. So y equals 0, so that's gone. Positive 2 over the square root of 3, so that's 2 the square root of 3 over 3 times x plus 1. And then y equals 0 again, minus 2 over the square root of 3, so minus 2 the square root of 3 over 3 times x minus 1 as we go through. And I think that I forgot to do a little thing with my equation. Let me just kind of pause a moment in myself and look at that. So, oops, +1. There we go. And so that's the equations of the asymptotes. Since I have this nice big slide, I'm also going to find then on this one the foci. And so we know, oh, I don't know what happened there. We know that, so we'll find the foci. And we know that c squared equals a squared plus b squared. So c is the square root of a, which is 2 squared, plus b, which is the square root of 3 squared. And so that will be c equals the square root of 4 plus 3. And so that's the square root of 7. And then our foci are at h comma k plus c and h comma k minus c. And so h, if you remember, is -1, comma 0 is k plus the square root of 7, and -1 comma 0 minus the square root of 7. So if I clean that up, -1 comma square root of 7 and -1 comma negative square root of 7. If I get that as a decimal just for my graphing purposes, that's -1 comma 2.65 and -1 comma negative 2.65. And so take a minute to make sure you get that, and you can have that. And then I'm going to go back to the previous slide, and I'm going to put in the foci. And when I put in the foci, I'm going to label them like that, but I'm going to graph them like that. So back to this slide. So my foci are at -1, comma 2.65, so kind of someplace up there. But when I label that, I'm going to call it -1 comma square root of 7. And then my other one is at -1 comma negative 2.65. And so that's a little harder for me to write it right in there. -1 comma negative square root of 7. So that's kind of what's happening there. Just another completing the square problem that gives us the a and b values so that we can then sketch the hyperbola. So you shouldn't have to do any notes on Friday, so that will just be work time. The rest of this time is also work time for you. You can be working on different things that are due. You have some homeworks that are due next week, and you now have the final exam review and the formula sheet, and then tomorrow will also be just kind of final exam review time for you. And so have an awesome weekend. I will see some of you on Saturday, and then we will be reviewing for the final on Monday and Tuesday of next week.